All right, so let's go ahead and start with that one. Minimize, okay, right click, and get my highlighter. Okay, so if you guys remember yesterday, Adam, we talked about PLCs, right? Karen, we did PLCs and we talked about what PLCs are, and then we talked about PLC programming, converting the schematic diagrams into actual language that you can put into the PLCs to talk to the equipment. Matt, this chapter, fiber optics, is a continuation of this low voltage communication type of chapters that we have. When you have a PLC or you have telecommunication system, you need means of sending the data from point A to point B. You have two options, a couple of options actually. You can have a twisted pair, Karen, like Cat5 and what's not, a set of twisted pairs where you can send all these data through these highways, or you can have coaxial cable, or the best and the most, the fastest and the most wide range for sending data is right now is fiber optics. So that's why we care about fiber optics. Any comments, guys, while we through this chapter at you? So you're familiar with when we did the low voltage, Adam? All these phone lines, right? We used twisted pair for them, Cat5 for data, right? And then between all these hubs or data, they use highways that's called fiber optics to transfer a huge amount of energy in the form of data from point A to point B. So that's what we're going to focus on hopefully today. Okay, a few things, Adam, about your choice of fiber optics versus using copper conductors, twisted pair, or coaxial cable. Why should you use a fiber optic versus using a coaxial cable or a twisted pair or a Cat5, right? When you're dealing with the, I know we did it a long time ago, we did it 3 times right now, guys. You laid out your phone lines, your phone outlets, phone jacks, as well as your data jacks, and also splitters for the coaxial cable and what's not. So this will be a continuation of why should you use fiber optics to transmit these data. Anybody have fiber optics in their house coming to your house? Karen, do you guys have any fiber optics coming? They're doing fiber optics all over in the rural Minnesota. So Adam, do you guys have coaxial cable or typically either coaxial? I get my high-speed internet through twisted pair, basically. It's phone line. So you can get your data, guys, through a phone line to 2 twisted pairs, or you can get them through Cat5. That would be 4 twisted pairs with higher quality. And or you can get them through a coaxial cable. You can have a coaxial cable coming to your house that gets you the data, the TV, as well as your phone if you want to. Or you can have a fiber optics. What's the difference between them is the speed that the data can be transmitted and how much data you can transmit over these medium. Okay, then we'll talk about construction of how do they build the fiber optics, guys. Refraction, the way the data is transmitted through fiber optics. Fiber optics transmit light, not electrical circuits. So we'll talk about refraction. How light is transmitted through fiber optics. Remember, in fiber optics, we transmit light. We do not transmit current. So yesterday, Matt, do you remember when we were talking about how we communicate with PLCs? And we said we have LEDs that gets lights received by a light sensor and gets a signal, or the LED will send, or the CPU will lit an LED, and then that LED will be picked up as a current and converted. So the whole up to isolation, the optical isolation that they do, this is very, very similar. They convert data into light, and they shoot the light at the speed of light, which is very fast, through a medium that's called fiber optics. And at the other end, they invert it back or convert it back into data in the form of current and voltage signals, and they dump it across your laptop and mine. Does that make sense? So that's basically what they're doing with this fiber optics. So we'll talk about the transmitters. You need to have a transmitters and a receivers with fiber optic transmitters and receivers. So you take my voice, which is loud, right? Convert it into electrical signal. That's step number 1, right? You convert to a microphone, you convert to electrical signal. Then you get it into a transmitter, which converts it into light, shoot it across the country with fiber optics. Then at the other end, you have a receiver that take this light, convert it back into signal in the terms of volt and amps, and throw it through a microphone or through a speaker so people can hear it. That's exactly what you're doing, or through a laptop. So that's your transmitter receiver. Different type of fiber optics cables, guys. They're glass and plastic ones. And the connectors that you can use for them. This is probably the most important thing. How do you terminate and connect these guys? Okay, discuss concerns in making fiber optics connection. I know you guys are designers, so when you become a project manager, Adam, and you have a fiber optic cable there, and you are in charge of this project, you have to pay a lot of attention to the installation and termination of the fiber optics, because if you don't install it properly or you don't terminate it properly, you're going to have basically a highway interstate full of holes, potholes. That's what guys, fiber optics like interstates for cars, right? When you have a freeway interstate, you can push so many cars through the interstate versus the alleys in your backyard, right? If you have an alley in your backyard in South Minneapolis here, probably, Matt, you have alleys, right? If you have an alley, so you compare the alleys, there's almost a twisted pair, compare the alley, the traffic, the car traffic in an alley compared to a car traffic in 35W freeway. Okay, now, well, the problem with the freeway, if it's full of potholes, these are the bad connections, it's going to slow the traffic and damage the data. So that's how I look at the fiber optics. Okay, fiber optics. Unlike copper, remember copper, when we talk about copper, we're talking about Cat5. You're talking about Cat5 or twisted pair, the twisted pairs, the pairs that we use, or you are talking about coaxial cable. So these are what we're comparing with. Immune through electromagnetism. So the nice thing is when you convert data into light and you put another power line right next to it, there is no electromagnetic interference. So immune to the electromagnetic interference, because you are transmitting lights. You're not transmitting current to interfere with it. So that's a very good advantage. The second and the most important thing, guys, is a high data transmission. The reason why we use it, Karen, is because we can transmit a huge amount of data for a short amount of time. I don't know if these are still accurate, but these are you're talking about 200,000 megabyte per second. And you guys, how much do you remember? What's your internet at home? What's the speed of your internet? Anybody remember? 12 megabyte per second. I think Comcast give you 12 to 40 megabyte per second. 12 to 40, that's what you get, most of the people get. That's enough to watch movies. So when you talk about 200,000 megabytes per second, guys, that's a lot of data, lots of traffic. I always compare it, Matt, as interstates. Remember in the US where all the states are connected through this grid of interstates? We don't connect them through alleys, do we? Imagine an alley from here to Texas, and you're going to drive at what, 10, 15 miles an hour in an alley? That's what twisted pair for you compared to the coaxial cable. Okay, very wide bandwidth. So in addition to high speed like 35W, Karen, you can run, what is the speed limit, 75 miles an hour? In it, right? The speed is high as well as it's wide, so you can push more data faster. Does that make sense? That's what, guys, and again, I'm not a telecommunication engineer, but that's the beauty of the fiber optics, is you can push so much data fast, so you can watch you streamline your movies, Karen, and watch it at any time you want. So, okay, substantially smaller and lighter in weight. That's another advantage too, compared to copper. They're light and small and light. Everything, Adam, when it comes to designing a building, light and small becomes a big deal. Why? So imagine if a high riser, right? Do you really want more weight than you need to? So less weight, smaller things tend to have better advantage than bigger things, bulkier, bigger things. Any comments, ladies and gentlemen, about fiber optics over copper, coaxial cable, and twisted pair? Matt, does it make sense? The interstate analogy. Okay, so what do? They have the signal duplex fiber optic cable. So your signal goes right into here, and you protect it, of course, either glass or plastic, and you send it in the form of in a form of light. Okay, the construction. The way they're constructed, guys, there's the core, and you're looking at the core in a second here. The core is made out of either glass or plastic, and that's where the light goes right through it. And then you need the clad here, or the cladding, to protect the core. So you need to protect. The most important thing about this one envelopes the core and provides protection for this core. So you have cladding on the top of it from the environment and give it a bigger, increase the size to give it more strength. So you have a glass or a plastic and wrapped up with the cladding, and then right above it, gentlemen, you have also another jacket, polyethylene jacket, which surrounds the cables. And what does that do? It protects the cable from the environment. So here's how it looks like. It looks like here's the core. Here, and this is where the light transmits light through this core. Then we have the cladding to protect the core. And then we have the sheath to protect both the cladding and the core. So to protect it and give it more thickness. Any comments, guys? Any questions about fiber optics? Adam, when you guys are with us, the electricians, did you terminate any fiber optics?
Actually, we didn't do fiber optics.
Did you? Okay. I don't think we had fiber optics at the time. I don't know if Karen is doing it now. Karen, do you remember any fiber optics termination? I don't think we have. I don't think we have a kit yet. I'm not sure if we change. Okay, so that's your copper, your core, which is a plastic or glass. Cladding to protect it, and the sheet to protect the whole system. Any comments, guys, about the construction? Any comments, ladies and gentlemen, about the construction? That's no rocket science into it. How fiber optics works? The light basically it travels in straight lines. So you transmit light travels in straight lines. So it provides a channel, a conduit for light to go around corners, right? So it's like a pipe that you allow the light to reflect right through this pipe, guys, and go from point A to point B fast at the speed of light. So it makes it possible to go around bends, that's like around the corners, conduct to the desired location. So you have, because I can't make the light go from here, guys, to the other wall, right? Through the wall. What you do is you put it through all these corners and move it, and the light, you channel the beam, the light beam, through all these cables, the fiber optics cable from the sender to the receiver. Okay, there's something called index of refraction, an indication of the speed. That will be on the test care, Adam. Index of refraction, the speed at which how good the index of refraction indicates how good the material is. It's a ratio between the speed of light over the speed of that particular material. So Adam, if you take the speed of light in vacuum here, compare it to the speed of light in that material, that will give you an indication of how good your fiber optics is. Any comments, guys, about the index of refraction? Index called index of refraction. Kieran? Comments, questions about this? So light travels in straight lines, and you provide the channel for the light to go. The problem with light, guys, if it's not in vacuum, it slows down a little bit, absorbed by the material. That index of refraction will give you an indication of how good of a material of fiber optics you have. How good of a material of fiber optics you have. Matt, does it make sense? Okay. So fiber optics, very simple, guys. You put any light coming out of any source of light. It doesn't have to be electrical light, any source of light. And it will channel this light right through all the way to the destination in the form of light. That's basically the concept is. So any type of light, put it at one end, at the other end, it will transmit through that cable to the other end. Now, obviously, Adam, we're not transmitting lights for the most part. We're transmitting data. So this is probably the single most important thing. You have a light source, a diode, an LED, and then you have your friend Chad here talking, and then you convert my voice through a circuit here into light. So you put voltage here, so let's say 5 volt, convert it into light. Now I have light here. I convert Chad's voice into light through an LED. Now the light will be picked through this cable, goes through this cable all the way to the destination. Now what do you guys think that the destination is? There's a photodiode, a diode, another diode or a transistor that activated by light and convert the light back into signal and dump it across the computer or across the speaker or what's not. Any question, guys, about how the light transmit inside? You can see it bounces from one side to the other, all the way through the destination. So it doesn't matter if the cable, your cable can be, you want your cable to be as straight as possible, but you can go around corner though with it, and it keeps going wherever you go to the destination, right? It just keeps following your inside that cable. You're transmitting lights. Any comments, guys? Any questions about how the light goes through this fiber optics? It refraction and reflections. Reflection, guys, right through it. Bounces from one wall to another, from point A to point B. Okay, then as it goes through the cable, there are losses, unfortunately. Some will bounce back, some will, if the termination is bad, will be lost, absorbed. So that's talking about losses, guys. Light escapes. There will be some type of light, guys, instead of bouncing and going all the destination, get absorbed and escapes through the cladding. Absorbed and escaped through the cladding. So that's part of your losses. And the greatest loss, as everybody will tell you, goes through the termination and the splices. Adam, every time you splice a fiber optic, you are creating basically a bottleneck for the data. And you need to be very careful when you, and there's a lot of technologies now. So splices are bad for fiber optics, bad. So you lose some data. So when you do the splicing, gentlemen, you need to clean and free of nicks, scratches, uneven scratches and uneven strands. So they have a kit, Adam, that they give it to you, whoever installed the fiber optics, Karen. They use a special kit that they terminate and cut and splice the fiber optics with all the cutting tools are very special cutting tools to make sure the termination is proper so they don't lose more data than we need to. Then you do polishing at the termination in order when terminated. Special hot knife cutting tool available. So what I'm getting into, you guys are not electricians, but there are, when you, Adam, when you become a project manager and they want to terminate fiber optics for you, I know if you're working for electrical contractors, right, you make sure that they have the proper tools to do the termination. That's all what you need to do. Any comments, guys, about the tools to do the termination? Terminations are bad in fiber optics. You don't do them good, you lose a lot of data. So if you don't do them good, these are like potholes in the Interstate 35W. Have you gone through one of them lately, Matt? See how bad they are, especially coming out of a bad winter in the great state of Minnesota. So you want them, you want them filled, these potholes, filled properly. Okay, so transmitter. So going to you need to transmit. You transmit light. Factor selecting transmitter. When you select your transmitter, that's going to take Chad's voice, convert it into a light. A couple of things. You need the wavelength. Can be measured by the color emitted from the diodes. So you have a different wavelength. Spectrum is another factor when selecting the transmitters. Color distortion that occurs because it affects the color distortion. So there's a lot of issues, guys. The color and the wavelength of the transmitter. These LEDs that you're going to use, it will affect how good your system is. There is numerical aperture. I'm not sure if I say that. It's called is the angle which light is emitted from the source. That angle at which the light is emitted from a source is called NA. Light sources generally is either laser or LEDs. So the only thing I would like you guys to remember, Adam, is your transmitters are either typically LEDs or laser. You transmit to convert into light. And at a certain angle, that's called numerical aperture. Any comments, guys? Any questions? At the different waveforms, a different spectrum width. Comments, questions, and there's a lot of specification, guys. We're just touching the surface on that one. Here's your transmitter, Karen. You take the voice that's coming out of is 5 volt. I'm going to take 5 volt Chad's voice coming out of this circuit. You convert this one into light. The light will bounce through this cable to the destination. So that's through a fiber optics. Any comments, guys? Any questions? You can use to convert the signal into light, either laser or diodes. Matt, very simple, huh? Take a laser or diode, convert your voice to a receiver. You have to buy the receiver. Now, transmitter. So this is your transmitter, Adam. The receiver at the other end, the transmitter is in Minnesota, the receiver in Texas. It takes it all the way to Texas. When they reach there, here's the fiber optics. Now, Chad's voice, God forbid, is going all the way here through the cable. Now, the light will shine on to this photodiode transistor, and it converts this one into 5 volt, and then it dump it back into whatever you want to call it, laptop, or speaker, or what's not. Any comments, guys, any questions? This data could be in the form of voice, audio, video, right? It could be audio, video, or data. Doesn't matter. You can convert an audio, a video, or data. Any comments, guys, any questions? So you take all the information, guys, transactions, credit card transactions, convert it through fiber optics. You can take movies, convert them and send them through fiber optics. It doesn't matter to the fiber optic cable if you're transmitting audio, video, or data. Any comments about the receiver and the transmitter? Does it make sense? Very simple. Okay, now of course, when you transmit, you have to be able to transmit and receive at the same location. So the Smarter Than Chad have a device that's called transceiver. So that will be on the test, Karen. Again, what is the transceiver? It's a receiver and a transmitter. So a device that receives and transmits. So transceiver, same in the same package. So you can receive and transmit. Photo detection devices. You have a photo detection device, of course, to pick and receive. There's also something called repeaters. With all the signals, guys, with telecommunication, the signal is very, it weakens over distance, Adam. So what they do is they take the signal and beef it up a little bit, amplify it. These are called repeaters. They amplify it. So it contains transmitters and receivers. It pulls the signals for longer distances in fiber optics. Reshape digital signals back into the original. It does they call it modulation, demodulation of the signal. So boost the signals and reshape it into its original form. So you can hear Chad, not as Karen, at the other destination, right? You want the form. You want to hear the people with their exact voice. Any comments, guys, about the transmitters and the repeaters? Transceivers receive and send. Repeaters take the signal all the way to Texas as we reach, give me a state, as we reach Iowa. In the fiber optics, we lose some data. What do? They have a repeater there. It takes the signal, beef it up a little bit, and keep shooting it. Does that make sense? They use these repeaters, guys, in every signal, in coaxial cable, and fiber optics, and everything else. You know, these things, they have they beef up the signal in order to reach the destination. Okay, here's how your transceiver, guys, looks like. It has a transmitters in it and a receivers. So dual, you can receive and send. You can transmit or send the signal, and you can receive the signal from different destination. Receive and signal into different destination. Comments, questions about transceivers, ladies and gentlemen? Receive and send the signal through the same cable. Connections. Talking a little bit about the connection. The connections are the weakest link, guys, like we talked. Air gap between the cables and the connector is a big deal. Changes the index of refraction, causing problems. So causing Fresnel reflection. When they terminate, Adam and Matt, if they don't terminate properly, part of the light, instead of continuing through the cable, it gets reflected back into the source. That's bad news. So my voice, instead of going all the way to Karen, say 5% of it goes back to me. So they try to eliminate this one by properly terminating the cables. Produce an optical resonance cavity, causes light to be reflected back to the transmitter. That's what they call it. So since that's reflectors, bad connection, guys, it will reflect the light back. Who cares? It will slow down the data and corrupt some of the data. So you have to pay a lot of attention to that. Okay, if you don't align the fiber optics correctly when you terminate them, part of the light signal will not be transmitted, so that's bad news, between the two cables and the devices. So when you do termination, Adam, and you have two fiber optics, here you go, fiber optics number 1, 2, guys, we need to terminate them. Great, you have to align them properly and terminate them properly and connect them properly. Otherwise, you're going to lose some data. slow and lose some data. Karen, any comments, any questions about termination? Is very important. Aligning the cables and terminate them properly, polish them, use the proper tools to cut the cables as you terminate them, because you can't have one single cable from here to Texas, can you? It has to be multiple cables fused together, attached together. So you have to do termination. Okay, fiber optics losses. They measure the losses, guys, in dPs for the fiber optics losses. Through poor connections and is measured in dPs. And here's what they do. The dP, guys, they take, I don't know how many of you did logs. So they take 10 times log 10 to the power output over the power input. How much power are you sending out versus how much power are you generating? That will decide how good of a system you have. They call it dPs for the fiber optics. So higher dP is bad for the fiber optics, lower dP is good for the fiber optics. So Adam, this is the efficiency of your cable. Can you guys see that? The efficiency of your cable is power out over power in. Any comments, Karen? Any questions? Did they put you to sleep, guys? No? Any comments, any questions? This is a good topic though. DPs, so they take the log. I don't know how many of you guys have you have scientific calculator. You can measure these. Take the power, take the log 10 of it, multiply it by 10, and that will get you the DP for the system. Okay, a few devices, coupling devices that you can use, guys. There's threaded ones, nothing to connect to rotation alignment. Okay, so you do rotation alignment for it. The losses for this system, if you have it threaded, is between 0.6 and 0.9 dPs. Bad. Peanuts, another way of connecting them. Alignment, twisted lock. You reduce it down to 0.1 the dPs. Can you guys see the idea is to reduce the losses? And there's a push-pull, and I don't claim to be an expert in these. Excellent alignment to give you the best alignment that you can do. And Adam, this is what you get in terms of losses. So if you were to pick which one based on these threaded, peanut, and push push-pull, which one would be the best? Obviously the push-pull, because it reduces your losses to 0.2 from 0.8. So these are the type of connectors that you guys use. Any comments, gentlemen, any questions? Comments, questions? Obviously you guys are, like I said, you're designers. Your job when you become a project manager is to know that, right? The more you know about the construction, electrical construction, the better project manager you will be. When you do the connection, Adam, you have to, what they do, connection are epoxied. They have epoxied and polished. So they use microscopes to check them, to examine the connection for possible problems. So they have a lot of tools, guys, to make sure that they are aligned properly and terminated properly. Connection toolkits. So the most important thing is your toolkits that you have to do. We have crimp tools, we have crimping dies, we have polishing bushings, we have polishing films, and what else? Cables and fiber strippers, microscope with the tripod, and what else? Epoxy, curing oven, all these. So when you're dealing with fiber optics, remember, you have your own set of tools that are dedicated to the proper termination and installation of that fiber optic cable. Can I get you guys to understand that one with all these toolkits? So you can't grab your electrician, journeyman electrician tool list that you bought, Adam, with us when you were here and say, I'm going to go now work on my fiber optic cable. So that's what I'm going to get you. Okay. So fiber optics, the main goal of the fiber optics, Karen, is to transmit data. There's another advantage of fiber optics is actually used as a lighting system. Lighting. Do you guys remember general lighting? So fiber optic lighting, they call it fiber optic lighting. Instead of transmitting data in the form of light, it transmits light in the form of light. So light for general, so you and I can see. Can be used what's the advantage? Swimming pool. Contains and fountains, and it eliminates the shock hazard. So Adam, if you have wet niche luminaires inside the swimming pool or inside the fountain, instead of putting an electrical lighting fixture that can get a shock hazard there, what they do is they have a fiber optic light device. and they send the light to that little fixture, guys, and in the form of light. So they generate the light somewhere else, and they transmit the light through a fiber optic cable into a fixture that distribute the light inside that fountain or inside that swimming pool, the bottom of the swimming pool. Can I guys get you to understand that one? General lighting system, and instead of using fixture like the one above your head, 2x4, right? They use fixture. Hey, morning. They use a lighting fixture. They use lighting fixtures, a fiber optic lighting fixture. You can put them located in outdoor areas for accents, lighting for buildings or walkways, supplied by single source of light. So you have a single source of light. Then you have luminaires. Luminaires produce no heat, right? Have no electrical connection. Lamp never needs replacement. Never need any replacement for lamp. So here's what they do. They have a device, guys, a couple of LEDs that generate light in this room. They put a fiber optics right next to it, and they transmit that light into each and every one of these fixtures. And these are fiber optics fixture. They don't have ballast in them. They don't have light. So what's the advantage of this? No electrocution, no shock hazard, no arc hazard, nothing. So hazardous location, good application for them. Swimming pool, where you don't want to put electricity so you don't kill people inside the swimming pool. So that's what they call it, fiber optics. I think we have there you go. Here's how it looks like, Adam. So suppose that this is my swimming pool right here. Okay, I have my swimming pool, and because I want to see inside the swimming pool, what they do is they have fixtures. These are fixtures, illumination fixtures. Can you guys see that? In fixtures. And then outside in a special room, can you guys see that? This is another room. Inside the room, they bring a 277 volt or 120 volt circuit to this illuminator. They call it illuminator. It generates light. It transmits the light right through this fiber optics to each and every one of these fixtures. To each and every one of these fixtures. Can you guys see that? Anybody have ever seen them? So they generate light in one room. They transmit light through fiber optics into the inside of the swimming pool or spa or a hot tub or what else in Minnesota? These are good now in the winter. And another application, guys, is also hazardous location, any hazardous location. What's the advantage of doing this, Adam? Is you don't have any electrical here. So if you go touch this fixture, nothing will happen to you. There's nothing in it other than light. Can I get thumbs up, Chad, for this? Understand? Okay. All right. So that's basically the fiber optics. Ideal for application. They also use them in museums, guys, as accent for valuable work of art because you don't want to damage them. Individual light source. They don't have electromagnetic field on them, so they don't affect others. Do not interfere with sensitive electrical equipment. You can put them right next to any communication circuit and they wouldn't interfere with it because they are light. And how do they look like? They look like this, Derek, my friend. You have an illuminator, which is your machine has multiple diodes. You generate light into this illuminator that could be in the first floor here at Dunwoody. You shoot them through the fiber optic cable as a light. And you bring all the here and you distribute them to this fixture right above your head and get yourself your general purpose using lights.
How many watts can you put out from those ones?
It's enough to get you a good amount of lights. I'm sure they will. Typically, it's an expensive way of solving a problem of lights, but you can put enough lights to get your general lighting system. So general lighting, you're looking at what? You're looking at 32 watts here. 88 watts in each one of these fixtures. So you can generate, remember the watts happen here. So that you can, I really have never used them. So I assume they can put probably 1,000 watt here, convert them into these fixtures. Good point though. So that's another application of fiber optics. Instead of, Derek, you didn't catch the part of it. Instead of using fiber optics to transmit data in the form of voice, Chad's voice and audio, video, and data, you can also transmit light for the sake of light, as in illumination. Okay, so that's all what I have, guys, for you. So what we talked about is fiber optics. Here's my fiber optic cable. compared to other sources, the twisted pair, basically the copper twisted pair, data transmission, conventional lighting system. So two application. You can use it to transmit data and voice in lieu of copper, and you can use it for conventional lighting. The way the light travels is through so-called refraction, basically bouncing from one wall to another, from Minneapolis all the way to Houston, Texas, or wherever you want it to go. The greatest problem with fiber optics is, Adam, if anybody ever asks you what's the disadvantage of fiber optics, poor connections. Connection, even electrical. The weakest link, do you guys remember when we were sizing cables, we said the weakest link in even a power system is connection. Because connection get loose, arcs, create problems. So connections, every time you terminate a cable, when you troubleshoot in the power system, and if the circuit is not working, the first offender in the circuit are devices because they have terminals in them, or wire nuts because they have terminals in them. Any place where you cut the cable, that's the first offender. Before you go, when you guys troubleshoot circuits, I don't know, you probably don't do a whole lot, but do you go right through the walls and start looking into what happened to the cable first? Is that your first? The switch, termination, the weakest link. The light, the connection here, the ballast, you know what I mean? That's the termination is the weakest link in any power or communication system. So that's what I have for you. I don't know if we have a couple of other pictures I would like to show you guys. I think we went over most of them. So we talked about, guys, the core is plastic or copper, and the cladding as the sheath to protect it. How it transmits. We talked, Derek, how you convert the signal into light. You shoot the light through this bounce from the walls of this plastic or glass tube all the way to the destination. At the other end, guys, it comes over here and it bounces to the LED optical fibers. So we get the LED source. At the destination, here's what destination. It goes to a photodiode, it picks it up and converts it back into a signal. We talked about the transceivers, 2-in-1, and here's all the termination, guys. Different type of termination, Adam, that you have to use with. And I have a friend who does this for a living. I mean, if you become good at the termination, they want you on every project in town. We're building a stadium right now. What do you think they're going to be doing? Fiber optics, all this telecommunication. Everything is going to be through fiber optics. So all these pieces and connectors and what's not, very, very important. Aligning the cables together. You misalign them, you lost a lot of data. And terminate them, polish them, and what's not. And we talked about the illuminator, guys, where this is a source where you bring electricity here, convert it through LEDs typically into light, and you shoot these lights through these channels, which is fiber optics, into so-called end fixtures, which is nothing other than just there's nothing electrical in it. It's just a fixture that distributes the light. Like this one, imagine this without the ballast or anything else, just a source of light coming through it. So here's the fiber optics, guys, a bunch of them. You can have many of these cables bundled together to send you more signals, different type of connections that you can use, plug-ins. Here's the kit that you need, Adam. The first thing when you're a project manager, you're going to buy your electricians a kit if they're working on this termination kit. And that's basically it, the fiber optics. This will fit, guys, into the PLC programming and PLC that we talked about, because we talked about communication and what's not. So what my goal from this chapter for you guys is, obviously you're not an electrician, you're not going to be terminating these things. I wish you would be at one time, but to be aware of it, be aware of the problems, and when you become a project manager, Derek, the kit, the alignment, all these problems you could face in the field. Any comments, guys? Any questions? Comments, questions? So what I have for you guys for the rest of the day, we're going to keep plugging at it. I do have 2 more chapters to go, so I'm not going to do them today. I'll give you enough time to focus a little bit on the project. Please, can I emphasize the word please? Let's utilize the time wisely, guys, and wrap up the Revit part of the project. Go back like Adam has been doing and adjusting it. If you guys have more time, because we have to do it tomorrow, please work on your homework for these. Please look at there are 2 pages, guys. You can read them, and the answers are really easy. So please work on your homework. Derek, any questions?
Pretty good.
Good?
Yeah.
Okay, thank you.